happy of it. I want to thank this group from driving down from Gainesville to be here. We thought we might have to do a video conferencing, but it's nothing like seeing them in person. So I'd like to welcome you to Miami, to Casa Bacardi. And your subject matter is evaluation and design of a decentralized alternative to conventional wastewater infrastructure in Cuba. And our Gatordale team, who's chairing this? Tony?
Yeah.
Okay, so you want to introduce your team members? I know you're one short, but you are a group of 4.
Yes.
So welcome, and the floor is yours.
You want to just do self-introduction?
Yes.
All right, we're going to do self-introduction.
Alright, my name is Antonio Diaz. I am studying to become an aerospace engineer. I'm a sophomore, but my research is on micro-air vehicles within the University of Florida. Our missing member, Will, is an electrical engineer, and he contributed greatly to the electrical calculations and financial costs.
Alex. Okay. My name is Alex Arias. I'm part of the Material Science and Engineering program at University of Florida. I'm currently a senior finishing the semester. And my research is mainly concentrated on electronic materials, but I also worked on this project in terms of the materials involved, cost analysis, and the history of the system in Cuba, the wastewater system.
Good morning, my name is John Cores. I am a senior at the University of Florida. I'm an aspiring chemical engineer. My research there is studying HUVEC cells, which are human umbilical endothelial cells. Nothing to do with the presentation, but I just have a general interest.
So I want to highlight here, may I take a second of your time, but did you get any kind of credit in school for doing this work?
No.
No, so you've done this
Just
on your own.
completely off on the side. We work nights on this.
I congratulate you once again for that. And John, I'm sorry for misspelling the name here. I caught it once, but I missed it the second time, so I apologize. But once again, Alice will let you know when you have 2 minutes to go. But thank you very much.
Can I say something before? Right.
Tell them what is your red
We still have some more to say for the introduction, but we just would like to thank our advisor. He's currently a PhD candidate. He's working hard on his research, but he also helped a lot and really helped guide us and organize us throughout the whole process. Is there anything you want to add? He's also in the environmental engineering department, so he was a great help.
Yeah. Also, one more thing, we didn't realize that our team name Gators Dale would be confused with Gators Dale. We eventually realized that, and that it means Dale, which is the traditional Dale, and that signifies doing amazing Latin engineering, and yeah, that was our inspiration. Okay, so today we're going to mainly give a presentation on a conceptual basis. We're not going to cover any rigorous calculations of the sort. That's mainly left for the paper. We're going to present the case as to why Cuba should adopt a decentralized approach for their wastewater system. So water is essential to life. It is the basis or the medium where complex chemical reactions can take place, such as DNA replication, protein synthesis. Is essential for every biological process. Anywhere we find water on Earth, we find life. And where we don't find any water, there is no life. So it's essentially a very important fluid to humans for life to continue. But through history, we've had several challenges. One challenge is that as populations in the world started to increase and people started to condense into cities, they started using pit toilet systems. They weren't lined, they were just holes in the ground with soil. So they would go ahead and defecate in these pits, and this was for basically like the regular class or middle class at the time. The upper class would actually have little toilets up in their castles, and they would just let the feces roll down the sides. So you definitely wouldn't want to stand in the way if it was being used. But for most of modern history, it hasn't changed. We still practically do the same thing. The only difference is that we use water to shuttle our waste away, rather than having gravity take care of it. But product of this, there were several cholera outbreaks throughout the world. There were several cholera outbreaks in just 1 year in the Great Britain Isles. There were approximately 30,000 deaths. And by 30,000 deaths, that's a huge percentage of the population at the time. It's not like saying 30,000 today. But a famous painter named Joseph Lagarde painted the scenery at the time. A lot of people thought it was really dark, it was very depressing. People were dying out on the streets,
Priests had to go and pray for the ones that were dying. Furthermore, they had no idea how this was transferred. They had no idea that cholera was a waterborne disease. They thought that it was airborne. So what they did was they would burn sulfur out on the sidewalks, which now we know is counterproductive because sulfur causes lung cancer. But they thought it would sanitize the air. But they didn't know it would sanitize their lungs as well. But along came a doctor named John Snow. He actually carried out a study where he started mapping where deaths were occurring around the city. He noticed that at the area where highest death rate, or the most deaths were occurring, was right by a pump. So with this data, he basically concluded that cholera was actually a waterborne illness. And with further investigation analysis, they realized that the pit toilets surrounding the area were leaking into the pump. So essentially, they were drinking their own waste. Once this was determined, people started to try to look for a very fast approach to solve the problem. But as an interesting side note, the pump is still around in the area. You can still go ahead and see it. This is actually in United Kingdom, in the England area. This is actually the pump. And interestingly, there's still a brewery around. And actually nobody that worked at the brewery died. And that's because they basically drank alcohol all day. And alcohol, yeah, alcohol actually kills the cholera bacteria. So they were basically safe. So
you can have your presentation right there, by the way.
Right. So I mean, if there's another pandemic around the world, where do you guys think we should head to? I think we should all probably go hang out at a pub. Maybe we'll avoid the plague, right? But then in response to all of this, they needed to correct the problem. So the fastest way to correct it is just to tie in the waste stream into the pre-existing sewer systems. The sewer systems at the time were just for stormwater drainage, so that the cities wouldn't flood. But since they were already laid down, they just said, hey, why don't we just connect our waste into it and take it away from the cities? It was a good first approach. It worked for a while, but populations kept expanding and they kept growing outward. So the places where all this waste was being sent to was starting to be occupied. And then we were facing, again, more illnesses and diseases due to the waste. Product of this, today we have treatment plants. So now we just don't dump our waste into bodies of water. We actually process it. And as time passes, the treatment plants start growing larger and larger and larger. You can see that this one's somewhat modularized. So this is like the most primitive part, where they have settling ponds and filtration systems, then chemical treating systems, and so on and so forth. As time passes, we realize that it's like a compounding problem. We always realize, there's another problem, there's another problem. So, as a matter of fact, last year in 2011, this is something that occurred in Fort Myers. One side of this body of water was actually experiencing algal blooms due to the surplus of nitrogen and phosphorus that was in the water, which can be somewhat attributed to wastewater streams because we don't have a good method of eliminating nutrients from the wastewater. On top of that, fertilizers from people's lawns was contributing to this problem. But in response to this, the EPA started developing new standards for eliminating nutrients from the wastewater stream. But Florida is suing the EPA because it would be practically impossible to reduce the nutrient contents of the level. It's not economical. It's estimated that the cost to reduce the water nutrient levels to where it should be acceptable is between $1 and $4 billion, which we know Florida, sounds like a number if Florida is going to be having a hard time to meet. So essentially we see a system that's broken. It's broken from the roots. And we're presented with an island that currently has practically no system. So rather than implementing a system that we know is somewhat inherently flawed, why not rethink the whole approach? We shouldn't be needing to go back to the 17th century to find solutions to problems that exist today. It is estimated by Cueto and de Leon that the retrofit and a new design for an American-style treatment system in Cuba would be approximately $4 billion. We're here to present another system which is going to be more economically viable and help eliminate all these other problems, which will stimulate several different markets and help improve the health quality of people in the island. So now I'm going to turn it over to Tony.
All right, well, Cuba basically has many options available to it to move forward with the technology. They can either stick to what Alex was saying and try to upgrade and retrofit their water treatment facilities, or they can move on to a more creative approach and go with the method of composting and desiccation. These are solid waste treatment techniques, so that instead of using water as a source of transport for our fecal matter, we would instead keep it as a solid state and treat it in that form, so as not to spread disease around in water and its aqueous solutions. Essentially, this will turn our waste into a commodity, and the importance of this is that we're creating a compost and a product that can be used in agriculture and even in small backyard gardens. But the critical thing is that commodity. This is what nature would expect from us, to use the reaction of decomposition to lead our fecal matter into the final product of compost that we could use in agriculture. The actual process of composting is very simple, happens day to day in nature. It's happening right now, probably. And it turns our raw materials of fecal matter, the organic matter, the carbon, the nitrogen, and the concentrated chemical energy, into the finished compost that can be directly applicable to agricultural uses. The process works primarily on the microorganisms present within the compost pile. They're naturally found, and they help this exothermic process occur. And the products created are heat, CO2, and water. The critical aspect here of heat helps speed up the reaction and also contributes to the elimination of pathogens, which is also very beneficial and critical in nature. Also to note here is there's a surplus of oxygen assumed. This is an aerobic system, and the benefit of aerobic composting is that it produces exactly that: CO2, water, and the pathogens are destroyed. In the case of anaerobic systems, currently found in septic tanks, is that they produce, instead of CO2, methane, which will be more harmful for the environment. To avoid that, the compost pile has to be given adequate oxygen through different means of aeration and also through bulking material, which is another benefit of this composting technique. Bulking material could be anything from dry leaves, twigs, coconut husks, anything available to Cuba that is, in day-to-day basis, usually considered a trash. So this is also another great benefit of this design, is that coconut husks, even sugarcane byproducts, the dry leftovers of sugarcane, instead of burning them, could be used as a bulking material within the compost pile, and it would provide aeration to the compost and maintain the carbon and nitrogen ratio that is critical in optimizing composting to levels of 15:1 for carbon and nitrogen. This diagram here demonstrates the simplicity of composting, and it's one step, as opposed to the complexity that modern day technology has led us to with conventional sewage systems and fertilizer production. The upper part of the diagram depicts how the capabilities of compost toilets and how the waste is treated through composting and through the heat of the reaction, killing pathogens. So that is the same equivalent to all this treatment here. While the chlorination and all the treatment that is required from a water treatment plant. And then this step here shows the whole process of fertilizing and growing our food, which is demonstrated on this part of our traditional system with fertilizer. All these fertilizers are artificially created, and they're a big part of the economy now. They cost a lot of money to develop and a lot of resources. Everything in this diagram on the bottom half is very resource dependent. Everything up here is resources that we already have and are considered waste. But in the terms of a compost toilet, all of what we previously considered waste is considered a product, and we take advantage of that resource. Many negatives are found currently in our wastewater treatment. There's leaching and runoff in the form of nitrates from our farms due to all the artificial fertilizers. and the byproducts of water treatment tend to be sludge, basically, that ends up in a landfill. Instead, we could use the nutrients for fertilization. So, with all these circumstances, we developed a concept for a design in urban Cuba. Now, this isn't a one-size-fits-all solution to all of Cuba, or to any nation, in fact. Composting toilets, unlike traditional toilets, are very open-ended. They can be designed to be optimized for many situations, such as urban, suburban, and rural areas. Normal water-based toilets, it's the same toilet everywhere, so it's not optimized for its environment. Compost toilets are meant to be optimized and take advantage of the circumstances around it. Our design is focused on the urban setting, so its dimensions are made to replicate the space found in a normal household and efficiently compost the material. As you can see, the parts here in general, there's a mixer for aeration, a desiccation drawer for drying out the final products, and the composting drum that will hold the majority of the contents. This here is a video demonstrating the aeration, and it also gives a more detailed view of the input and output holes of the drum. This is the bottom side of the drum with a mesh for drainage. Again, the aeration is critical for providing oxygen and creating the aerobic process. This slide here depicts the movement of changing the compost into the desiccation drawer. Once it has fully composted, we could put it in the desiccation drawer, and this drawer will drain very readily and dry out the final compost so as to further help eliminate pathogens by eliminating water from their habitat. And now,
Alex.
Yeah.
Okay, so here's a quick little analysis on the economic viability of this type of system. We didn't present the rigorous calculation involved with this, but the paper does present it in detail. So initial capital cost to install these systems, as presented by Cueto and De Leon, it would cost $46 billion to implement a conventional type system, much like in the United States. But it would only cost about $2 billion to implement the composting system. And even over time, with the annual maintenance and operating cost, when you look at the energy and the annual maintenance cost, and then sum them up, composting toilet is definitely more economically viable, cheaper alternative. This is also not including the market value of fertilizer. So once the market value of fertilizer is included, the total annual cost is expected to go down to maintain this type of system. The prices of fertilizer are also expected to increase since oil dependence is increasing and also oil supply is decreasing. So these are the quantitative benefits of implementing such system, but John's going to cover the non-numerical, less tangible benefits of implementing such a system in Cuba.
All right. So all this dialogue that we have here about the benefits of composting toilets open up a discussion as to the sequestering or sequestration of contaminants, bacteria, viruses, parasites, etc. The monetary issues involved with that, and the effects that it has on nature. And basically, it's an improvement. Listed here are the main culprits in human feces: bacteria, viruses, and parasites. Of particular interest to Cuba are the parasites that, I don't want to say wreak havoc, but they do have a great impact on our youth and society there. Okay, so that is gross. This is our compost toilet. What are the stigmas behind compost toilets? People think compost toilets, they think dirty, gross, antiquated, latrine-like technologies. That is an error. The actual grossness behind that is that there's such a lack of information out there that this is the expression people put on their faces when they're like, I'm installing a compost toilet in my home. That's gross. The reality is that these machines, because nowadays they are machines, they're not just this model made of wood. They're very efficient, they're very effective at killing off bacteria. Heat, given a certain amount of time, certain amount of conditions, will kill bacteria, and that was listed in the graph previously shown. But not only does it provide intrinsic human values, the toilet, it also provides environmental and biological benefits. A lot of our society has this out of sight, out of mind mentality, which basically says you can flush it down the toilet, it doesn't bother me, it goes somewhere and it gets dealt with. What the compost toilet does is it brings that to your home and it says, well, this is what's going on. This is what you should be thinking of. By out of sight, out of mind. And basically this is just to depict, the situation. Like, you're dumping your waste into your rivers, and in a result, you're harming yourself. Okay, so what we propose for Cuba is this adding to the existing municipal waste infrastructure. So our idea is you have an output from the household, which is a mediocre compost, a mediocre fertilizer, which is compost. Right now in place, we have a system of pickup of trash from the homes. Well, this could be the new trash. You pick it up, you send it to a factory. The factory deals with it and makes it into fertilizer. The fertilizer gets sent to the agricultural industries, and we have this new economic sector in Cuba. And all you have to do is, you get it. As well as, and this is the second thing, which is very interesting. The sectors in Cuba in economy can be divided, I guess, broadly into these three services, encompassing the majority of it. And with this composting technology, you invite a sense of eco-tourism, a sense of bettering the carbon footprint, green revolution type ideologies that will further feed to the fire of the services in Cuba, people coming in, comparable to like the industries in Costa Rica, where you have people coming in to view nature, et cetera, et cetera. So our conclusion, I guess, is that, like Alex said, Cuba is a tabla rasa, or rasa. It's basically a blank slate where you can do so much because there's so little right now in place. There is no wastewater infrastructure to deal with the current needs. So what we can do is just revamp it, skip generations of technological evolution, and be in a better place a lot faster than is seen in other countries. And that applies to not only wastewater, but telecommunications, electricity, et cetera, et cetera. I know I have 2 minutes, so these are our. Do you want to,
yeah. There's a brief list of our resources. All right. So if you liked any of the pictures, you can find them. Thank you very much for your time.